Hey guys, in this video we're going to solve log equations. So there's two cases that we're going to talk about. So the first one, kind of similar to when we were solving exponential equations. The first example is when you have a log on both sides. Now the base has to be the same. So you see for this example, I just left the base the letter B because it doesn't matter what the base is as long as it's the same. If it's the same base, the arguments are the same. Similar to the exponential equations, when the base is the same, the exponents were the same. Same concept. So this argument, sorry guys, equals this argument. And then you just solve that for x like normal. So I'm going to subtract 3x on both sides. I'm going to add 6. So I get x is equal to 4. Now, with a log equation, your answer can't make the argument negative. Because if you look at the graph of a logarithm, let me get my mouse out of the way. The graph of a log equation, I don't know if you remember or not, but it looks like this. There is a vertical asymptote. The graph does not go into the negative side of the graph. So your answer for x is allowed to be negative. But when I plug that in, my original argument has to be a positive number. So 5 times 4 minus 6, 3 times 4 plus 2, I have to make sure that those are both going to be positive numbers. And so 20 minus 6 is 14. 12 plus 2 is 14. It's also a good idea to check and make sure they are the same. So that works out. All right, so example number 2. This log, whenever it doesn't have a base, it's automatically like an invisible 10. So keep that in mind as well. We've talked about that, but it hasn't really come up a whole lot, but it's going to come up a lot in the next couple of lessons. All right, so the base is the same, so those are the same. So I would add x to both sides, add 8, divide, and I'm going to get that x is equal to 7. So watch what happens when I plug 7 in for x. 6 minus 7 is negative 1. 7 minus 8 is negative 1. But if you tried in your calculator to figure out what the log of negative 1 equals, your calculator is going to say error. Because negative 1 is not in the domain of a logarithm, so therefore this log does not exist. So in a situation like this, your final answer would be no solution. So that's why you have to make sure you go back and check. All right, case number 2, these do not have a log on both sides. So you're going to know that you need to do it this way when you look over at the right-hand side and you don't see a log. So I'm going to have to change this to exponential form. So it has to look like this. Before I can do this step. So same thing with exponential functions. You know, if I'm multiplying by something, I'm going to have to get rid of that. If I was adding or subtracting something at the end, I would want to get rid of that first. But this example is good to go because it's just the base and the argument. So if you remember, the base of my exponential is the same as the base of the logarithm. The exponent was what's on the other side of the log. And then remember, the whole purpose that we're doing this is because I want to separate the 4 and the x minus 2. So the x minus 2 goes on this side. So one little trick that might help you when you're doing it as a log is it kind of just goes like around in a little circle. 4 to the third power equals x minus 2. So that could just be a little trick that you use. So 4 to the third power is going to go into the calculator. 4 to the third power should be 64. And then just finish solving for x. So I would have to add 2 to both sides. And I still need to check and make sure that this is not going to be negative, but 66 minus 2 would be fine. All right, some special case logarithms. Again, this hasn't come up, well, this one has, we've seen this a lot. But these special cases where the base is invisible. So when you see ln, you should know kind of from last week that the base is e. So when I go to convert this to exponential form, it'll be e to the second power equals x plus 3. So e to the second power will go into the calculator. It's going to be a decimal because e is not a rational number. So I don't have a calculator here with me right now, so I'm just going to leave that as e squared. But then I'm going to look over here and see that I'm not done because I still need to finish isolating x. So I have to get rid of that plus 3, so I'm going to have to minus 3. So then I could just figure out whatever e squared minus 3 is. And again, I would want to plug it in and make sure that it didn't make this negative. I'm pretty sure that this is fine because e is almost 3. So that this is going to be a positive answer. All right, number 5 is another special case log. When it just says log and there's no base there, it's an invisible 10. So again, I'm going to have 10 to the negative 2 power equals 2x plus 1. So there's my base. This is my exponent, and it equals 2x plus 1. So again, I don't have a calculator, but you can just plug that into the calculator. Just spiraling back to what negative exponents mean. It means the reciprocal, and 10 squared is 100. So this is the same number as 1 over 100. All right, and then from there, I still have to finish isolating x. So the opposite of plus 1, I'm going to have to subtract 1, and I'm going to have to divide by 2. So minus 1, and then divide that answer by 2. So actually, let me go ahead and get a calculator, because I think this one is not even going to work. Let me see. So 1 over 100, and I'll just show you. 1 over 100 is the same as if I did 10 to the negative 2 power on the calculator. So that number, minus 1, divide that number by 2. Let me just check and make sure that it's not going to make this negative. So 2 times negative 0.495 plus 1. Oh, and that works. So this is good. All right, so those are the basic concepts, and I'll write this here again, but like the formula for swapping them back and forth. Alrighty. When we have b to the power of x is equal to a, that turned log b. So that's the little formula that we're using to do these problems. The base of the exponent, the base of the log, and then in both cases, when you make the switch, these two things swap places. So use that if you need to, for the next couple of days. You might want to write that down if you are still having trouble making the swap back and forth.